Okay, I'm gonna give you a quick video on the API 1104 20th edition. It's Appendix A. It's Alternative Acceptance Standards for Girth Welds. This is very important. A lot of people is not aware of this appendix here in API 1104. It's a very generous appendix, and we're going to go through it. I'm going to try to go through it as fast as I can, but some parts of it is kind of difficult with the formulas, and that would be a video of itself. But let me give you an example on WPSs. Let's go to this WPS, and I have to blur out a lot of stuff because of confidentiality. But let's look at this procedure here. It's a welding procedure specification, weld procedure specification. But right here, it says Industry Welding Code Standard. It says API 1104 20th edition with Appendix A / workmanship. As I tell all my students, always read your notes. Down here, 4. Always read the notes. And always know your procedures. You want to know about your maximum time between the hot pass and the root. And the hot pass and the fields and so forth. You need to know that a weld has to be completed within a certain amount of time, or if none of this stuff occurs or happen, you have to cut it out and redo it. But like I said, let's go to this note number 4. And you go down to the bottom, and your notes are written here at the bottom. And it says, for mainline welding with this procedure, IWM, and gas metal arc welding short circuit root completion, engineering critical assessment criteria applies. So ECAs applies when you're welding with the automatic welding or mechanical processing. With this particular procedure, not all procedures are the same. And then if you weld with shielded metal arc welding, stick welding on the root for completion, workmanship criteria applies, and that's a stricter application when you do workmanship. But the ECA is very generous, as we're going to go through it, and I'm going to show you what to expect if you welding with an automatic welding system. And the company have to do CTODs, fracture testing, before they can apply this ECA code. So let's go to API 1104. Let's go to Appendix A. And we won't spend too much time on this. It'll take forever. So I highlighted some stuff, but I'm going to read this first paragraph for you. Typically, but not always, the fitness for purpose criteria provide more generous allowable imperfection length. Additional qualification tests, stress analysis, and inspections are required before you can use the fitness for purpose criteria as engineering critical assessment. So it's called an ECA. You'll hear people say ECA. So it's very generous. If you go through this criteria, say the fitness for purpose criteria in the prior version of this appendix require a minimum CTOD. And CTOD stands for crack tip opening displacement. So you'll see that within this spec CTOD toughness either from 5/1000ths of an inch to 10/1000ths of an inch, and we're independent for any higher values of fracture toughness. Improvements for welding consumables and with more precise welding procedures, especially with the increase of mechanized or automatic welding processes. This is it's a very strong weld, and that's why they use this acceptance, this alternate criteria, Appendix A, because you're allowed a lot more, like undercut on the cap, and for this to be verified, it has to be verified by either radiography or auto UT, ultrasonic. So you can visually look at it, but the final say is from the UT or ultrasonics, because they're using the volumetrics and everything. But we're going to go through this, and it got different options you can use, option 1, option 2. We're not going to get into all the details, but I highlighted some stuff. This appendix provides procedures to determine the maximal allowable imperfection size. It does not prevent the use of Section 9 for determining imperfection acceptance limits for any welds. Use of this appendix is completely at the company's option. So it doesn't really eliminate the Section 9, but if the company has adopted this alternative method, then it has to be verified by either UT or X-ray. So as an inspector, you can visually inspect different things. You see porosity and you see maybe undercut, but the final say is by the UT or radiography. So once you change from automatic to stick, you have to go from this alternative to the workmanship. And if you start going to the workmanship, that's a tighter spec. So once you change from automatic to manual welding, you see in the procedure we looked at, you have to use the workmanship. You got to go back to Section 9. So that gets very tight. So the company spent a little bit more money to do this alternative testing, your CTODs, your fracture tests, so that they can get more production and the quality of the weld doesn't have to be as strict as the workmanship. So that'll increase your production and it'll cut down on your repairs. Okay, right here it says the primary purpose of the appendix is to define on the basis of technical analysis the effect of the various types, size, and shapes of such anomalies on the suitability of the whole weld for a specific service. And right here it says welds and pump and pressure stations, repair welds, fittings, and valves in the main line are excluded from this. So when you start dealing with valves and repairs, you have to go back to the workmanship. You can't use this ECA. Okay, I will read a lot of this to you, but I know it's going to be limited in time, so I'm going to just pause it right here and you can read through some of this. It's good information. It's good to know, especially if you're going to be out on the job doing inspection. You need to know your procedures, what you can and can't get away with. And your WPS is very important. Know what type of gas, your wire, your travel speed. You need to know your essential variables. If you go outside those essential variables, it's constituted. So anytime you go outside an essential variable, you have to have a procedure for that. So if somebody's welding outside of those essential variables, that weld is no good. So it has to be cut out and redone. So make sure you understand your WPS, weld procedure specification, and always read your notes. Your notes are very important. And let's get down here. You're going to see a lot of formulas, and I'm going to do another video to break down these formulas on how to do them. And that takes some time. It takes time to make videos like that because you have to put up the calculations and you have to just show how everything is done. So in this Appendix A, I just highlighted some critical stuff that you should pay attention to. And like I said, always read your notes down here. Always read the notes. It gives you references to everything else. So I'm going to let you read over all of this. And like I said, I don't want to take up a lot of your time. You can pause this video and just read through. And if you have any questions, just put them in the comments. If I can't find the answer, I know somebody in the industry that know the answer and we'll reply to you and get this information back to you. Weld procedure right here. Qualification of welding procedures to be used with this appendix shall. Remember the word shall is mandatory. Should is recommended. So you're going to see should and shall a lot in when you're dealing with procedures and welding. Like it says a weld should be no more than 1/16 of an inch high on the cap. So it says should. So it's recommending something, but if it says shall, that means it is mandatory. So it says this qualification of welding procedures to be used with this appendix shall be in accordance with the section 5 and 12 of this standard. So you go back to workmanship with the additional mechanical property testing in accordance with A 3.2. Requirements: tensile strengths shall be equal or greater than the specified minimum tensile strength of the pipe, and the specimen should not fail in the well. Should not fail in the well. And this right here is what your tensile specimen should look like if you're getting ready to pull it. And it should not break in this well. It should break on the outside. So the well should be equal to or stronger than the base metal. Then you got your Sharpie result. Sharpies, this is where you take your results from. And you also going to do Sharpies in your heat affected zone. And I'm not going to read through all of this. It's just showing you some more pictures where you should take your specimens from. And the CTODs, your fracture testing, your crack tip opening displacement. You're going to go through see a lot of stuff, and I'm going to show you something that's very important here towards the end, or I may just go down to the bottom so that you can understand what these different symbols mean, letters and numbers. And this right here, CTOD test, toughness testing, and I'm going to do another video that goes into more detail. I can sit here for hours and go through this, but I don't have the time, and I know you don't have the time to go through one video. Sometimes it's good to make different videos on these. And your notch, they're showing some more figures. Planar imperfections. The length and height of an imperfection and its depth below the surface must be established by appropriate non-destructive inspection techniques or otherwise justified before a decision to accept or reject can be made. Like I said, as a CWI, you can mark up something, but you cannot call it a repair. It has to be verified by UT or X-ray. So that's why this alternative standard, Appendix A, is very generous. So it allows the welders or the company to get away with a lot more stuff because they have did the fracture and the testing and everything to verify that this is all acceptable. And whenever you're qualifying welders, you go to your workmanship. That's how you qualify welders. So it's at a higher standard. So you go to section 6 to do your qualification of welders here in the API 1104. But remember that API 1104 is a standard. It's not a code. It's just a standard that companies use to write their procedures. The company's decision overrides 1104. So you may, in this procedure or in this API 1104, it may require 1/16 of an inch weld reinforcement on the cap, but the company could allow 1/8. So it's their decision. So this is only a standard. This go through a lot of more formulas. Like I said, we'll make a separate video about this and to learn what all of this stuff mean and the pressures and the stress. And it'll take some time. We'll just sit down, and it may take an hour or two and just go through each one of these things. But I'm just highlighting some certain stuff that you should know as a CWI when you're dealing with an alternative code, or you using this Appendix A. This goes, and math is very important. It's math everywhere. You're going to always use the lesser of the number. If it's calling for 1/4 of an inch or 1/8 of an inch, you use the 1/8 of an inch. And I'm going to give you an example of some of this. And I'm going to let you read through some of this. And let's just go to the example of option 1. It says the following is an example to perform an ECA with the option 1 methodology. So this is we're going to give an example of 24-inch pipe outside diameter, and the wall thickness is 1/2 inch, and it's a grade API 5L x 70 steel, 70,000 pounds per square inch is considered. After reviewing sections A1 and A2 of the appendix and consulting with the project's engineering as required, it is understood that the maximum axle design stress is 61.5 KSI. K stands for kilos, so that's thousands. So it's 61,000 pounds per square inch. Weld test data conducted per the requirements of appendix indicated that the minimum CTOD value is 11 thousandths of an inch. These parameters are summarized as the following. You got the pipe diameter, the wall thickness, your specified minimum yield strength, specified minimum tensile strength, your CTODs, it's 11,000 pounds per square inch, and then you got 61,000 pounds per square inch right there, and allowance for inspection is 50 thousandths of an inch. We're going to try to go through this and that you understand. We're going to look at this chart. It says allowable length pipe circumference, allowable length pipe wall thickness. So this chart can be a little confusing, so we're going to go over it a little bit right here. So you got figure A7 and figure A8. So here go how you do this. Step 1, determine the flow stress. So flow stress is substituting the 70 KSI. Remember we said 70 KSI is the specified minimum yield strength right here. So you substitute that in. So you got 70, then you got the 1 plus 21.75 over 7 and 2.3 to power equals 74.76. So you need a scientific calculation to do that. But note this note right here. Note that for this example, the flow stress can alternatively be determined by the average value of the specified minimum yield strength and the specified minimum tensile strength. Or in this case, it's 76,000 pounds per square inch. So it's saying take these two right here, these two numbers, the 70 and 82, add them together and divide by 2 and you'll get 76. So we're going to substitute this number right here for 76. Like I said, this is just an easier way to do that. The next thing you want to do is determine the applied load level. Okay, the load level P is a PR. That's for load level. It's now calculated by inserting the aforementioned values of A and F. So here go how you do it. So the to calculate this right here, apply load, what you want to do is take your 61.5, which is up there at the top, plus divided by your 74.76, what we came up with. This what you get 0.823 or 823 thousandths of an inch. So once that's determined, that's how you determine. And I'm going to go back up to the chart. So we're going to be dealing with this number right here, 825. So we're going to be dealing with that number on the chart. I know this stuff is really confusing, but I'm going to take another video and go through just these steps. Okay, step 3, you want to determine the initial allowable imperfection size. So we want what imperfection sizes we want. So figure 7 is utilizing to determine the initial allowable imperfection size. So the CTOD is greater than or equal to 10 thousandths of an inch. So the curve for the PR, remember we highlighted it, is 0.8 825 thousandths of an inch, and the figure is now used for the interpolation. The available imperfection size is tabulated in Table 1 and shown in Figure 9. So you got your Table 1 right here, and your Figure 9 is right here, okay? So here you go. Shown in the second column of Table 1, this is the second column, are derived by multiplying the allowable height, pipe width value by the wall thickness, which is in the example is which is a half inch, 500 thousandths of an inch. So you go 0.5 times 0.5 to come up with this allowable height. That's the height of your imperfection or defect. Okay, the allowable length is calculated by multiplying the allowable length pipe circumference quantity by the pipe circumference. So you go pi times diameter. So pi is 3.14 times 24, and then you multiply it by this number right here, and you get this number. So that's how you get your allowable length. So if we go back up to that chart, a half inch wall thickness. You remember we looking at the 825 thousandths. So you're looking at 825, let's see, 825 thousandths. So you're looking at this chart. This is the line. We're going to be using this line right here. So that's where this number is coming up. That's your CTOD number. But they simplified it here in the table. So they already broke it down. Most procedures already have this information right here. So to determine the height, assume the height uncertainty is lesser than 8% of the wall thickness, or 60 thousandths of an inch. So 8% of 500 thousandths of an inch, or half an inch, is 40 thousandths of an inch. So you got to use the lesser. So allowance for inspection is equals to 0.050 inch. So imperfect height adjustment. So allowance for inspection assumed height uncertainty is 50 thousandths of an inch minus 40 thousandths of an inch. So uncertainty is 10 thousandths of an inch. So that's your adjustment right there. So from 250,000 down to 240 thousandths. So we looking at this chart right here. This is the acceptable imperfection heights and length. So they give you a range from 0 to 5. What's that? 0 to 50 thousandths of an inch. You allow the height. That's the height. This is the length. So you allow 8 inches. So if you're looking at 5 thousandths of an inch to 150 thousandths of an inch, 3 inches. So if it gets higher than 15 thousandths, 150 thousandths of an inch to 240 thousandths of an inch. So anything over 240 thousandths of an inch, you're not allowed any length. So if it's higher than that, regardless of what the length is, you have to repair it. So this is just a chart of what we just discussed right here and here. This is a chart right here. Is this right here your allowable height, which is 0.254, and you go down here to get your allowable length. And this right here gives you some background on the fracture assessment diagram, FAD. And these are some formulas that they came up with, and this stuff, like a lot of engineers or lawyers come up and wrote all of this stuff, and this will have to be another video on itself to explain this CTODs, this fracture stuff. So I won't waste any more time on this, but I would just want to go down to, these are more formulas. Like I said, we will have to get out the calculator and just go through this one by one, give examples, and that's on another video. But this is right here is more for the UT or the level 2 and level 3 personnel that would be determining if these impurities or defects are acceptable or not. And I'm gonna let you read through some of this. I'm gonna just go through some of the acceptance criterias. This right here is acceptance limits for buried volumetric impurities or imperfections, defects. So if you got porosity, it says the lesser of T4. Let me get this bigger so you can see it. It says porosity, what is acceptable? The lesser of T divided by 4, that's thickness divided by 4, or a quarter of an inch. So we're dealing with a ½ inch. So a ½ inch divided by 4 is 1/8 of an inch. Then the length would be the lesser of T divided by 4, or a quarter of an inch. So we know we only allow 1/8 of an inch. So 1/8 of an inch. So slag is the lesser of T divided by 4, or a quarter inch. So that's the same thing. You're allowed only 1/8 of an inch on a ½ inch wall, and you only allowed 4 times the thickness. So 4 times a ½ an inch is, you only allow 2 inches. So arc burns, this gives you your requirements for arc burns. Arc burns may occur on the internal or external surface of the pipe as a result of inadequate arc strikes or the improper grounding. So the arc burns are acceptable. And this right here gives you the width and the length, and it's very generous. You know, it says the lesser of the thickness or 5/16 of an inch. So that's a lot. You know, that's on the width, and then you got the same thing on the length and the depth of the bottom of the crater. It's 1/16 of an inch. So you're allowed a lot with this alternative procedure or alternative code or standard. That's Appendix A. You're gonna go on down, and I'm gonna explain this a little bit. But before we explain that, let's go down here and understand what all of this stuff is. You know, you need to read this and know what all these little symbols mean. T, the nominal wall thickness. You got your KR, toughness ratio. And a lot of this stuff right here is for the CTODs. But there's certain stuff that you need to know when you start looking at this. So let's look at this right here. I'm going to try to explain it the best I can. This right here is interaction exists if. Now, interaction, that means when you get two pieces that are close together, they exist when this S right here, this is the space between these two imperfections. I call them defects. So if this space is less than 2C1, so this is 2C1. So if this space right here is less than this imperfection, then you will have to add these together and make the repair. So if interaction exists, effective imperfection size is, okay, so AE equals A2. So you will have to repair A2. If these two come together, if this space is too close together, you have to repair this. But in this case, you also have to do this right here. So 2C1 plus the space plus the 2C2. So you got to repair all of this, not just this. You have to do it all. So that's how you determine if something is interaction exists, if these are too close. Now, if this never existed right here, this would probably be acceptable because C1 right here is less than C2. A1 is less than A2. So this would be okay if this wasn't here. Since this is here, you need to repair all of that. All right, let's look at one more example and we'll cut this video off. I know I've been going too long with this. So S1, that's the space between these two defects or imperfections, is less than 2C1. So if this space is less than this, then you have an interaction that occurs. So if that's the case, C, all of this would equals 2C1 plus S1 plus 2C1. So all of this will have to come out, all of this. And let's look at this, S2, this space right here, this is S2, the space is less than A1. Let's find A1. Where is A1? Okay, if it's less than A1 plus A2, okay, there you go. Then it becomes interactive. And this is what you have to repair right here. So you go A1 plus S1, the space in between, and A2, you got to repair all of that. So these are different cases. And I'll let you look at all these other cases. So this is more for CWI. It's good to know this information, but this is more for your level 2s and level 3 UT personnel that specialize in these areas of UT and X-ray. So that's part of their jobs. Like I said, with this alternative code, we can identify stuff, but it have to be rejected by non-destructive testing like UT or X-ray. And like I said, I do more videos about this Appendix A, and it's a very complicated appendix, and it's more used for UT and X-ray. But like I said, always understand your procedures. Read your procedure, weld procedure specification, and make sure you read your notes, because you may be inspecting by workmanship when you should be inspecting by Appendix A. And that Appendix A allows more leeway, so it's more generous. So you probably, going by workmanship, you are repairing something that don't really need to be repaired, and that slows down the job, and it gets into the owning company pocket and the contractor's pocket. So make sure you understand if you're using your workmanship spec or your Appendix A. All right, if this video helps, subscribe to my channel. And if you want to take any CWI prep tests, look in my description below. I have the Part A, Part B, and Part C. The Part C would be over API 1104. All right, thanks, and enjoy the rest of your day. Don't forget to subscribe, like, turn on your notifications, and share this video. Also leave comments. Thanks for watching welding and stuff.